Okay, good. So let's just go through this one. Now, clearly, are you happy that we're not going to get the same matrix? How do we know? How do we know that A times B is not the same as B times A with matrices? Yeah, good. Are you happy? Because here, we got a 3 by 3 matrix when we did A times B. But now we're doing B times A, we're expecting a 2 by 2 matrix. Now just pause for a second, this is weird. Because if I wrote something like this down, let's take like 3 times 4, would you be happy that this would be the same as doing 4 times 3? Yeah? Does anybody know the name for this when we can switch the order around of an operation? Begins with a C. Does anybody know? Does anybody know the name for this if we can switch the order around of an operation?
Yeah, if we change the A and B, no?
Yeah, so okay, with this one, so 3 times 4, that's the same as 4 times 3. Yeah. So we call that a commutative operation. In other words, multiplication is commutative. It means you can do it in either order. So 3 times 4 is the same as 4 times 3. Okay, another example would be with addition. Okay, so 3 plus 4 would be the same as 4 plus 3. But for example, if I did division, that would be non-commutative because you're happy 3 divided by 4 is not the same as 4 divided by 3. Okay, so commutative means you can do it in either order. Okay, just think of like a commuter. Like a commuter can go to work, but they can also go back the other way as well. It means you can go either way. Okay? But you notice with matrix multiplication, you don't get the same matrix if you swap the order of the matrices around. Okay? So with matrices, multiplication is non-commutative, which means that you need to be careful. Okay? So if I give you a multiplication of 2 matrices, do not assume that you can do it either order. You don't need to be careful about the order. You do, right? So if I give you, say, in an exam situation, here are 2 matrices, find A times B, watch what the order is. Like, don't go ahead and do that because you're not going to get the same answer. Is that okay? Oh, that's an important point. Yeah? Good. Okay, fine. Did anybody do this? Okay, so for example, that's first element there. So that's first row, first column. So first row, first column. Has anybody actually filled this matrix in just for time? What do we get? 41 here. What goes here? So first row, second column. Sorry? 33. This element here? 100. And this element here? 90. 19. 19. Okay? Do we all agree with that? Yeah, do we all get that? So it's literally the same idea as here, so I don't want to go through it in more detail. Okay, but just make sure you do get the same thing here. So if you're not sure about how to do that, then go back and check how you can do that. Yeah, you just simply think about the positions of each of these 4 elements, rows and columns. You just kind of think about them in terms of this matrix.
So we have in the second one, you have to calculate everything like that.
Okay, so let's just do that first one, for example, just to make sure we're okay. Okay, so that one will be the first element, will be the first row and first column. You happy with that? Yeah. So you're going to take the first row, which would be this row here, and the first column, which would be this column here.
Okay, I got it.
And you multiply corresponding elements together, just like we were doing before.
Now I got it.
Good, fantastic. And you just keep going through like that. So I always say, right, when we multiply matrices together, we can almost come up with a recipe. Okay? What's the first thing we do when we go for matrix multiplication? What's the first thing that we check? These things? Yeah, the dimensions, right? So we check the dimensions first. Okay? So we get a something times something matrix, that's the first one. In this case, it was a 3 by 2. And then we get a something times something matrix, the second one. In this case, it's a 2 by 3. And what do we need to check about the dimensions in order to make sure that we can multiply them together? What do we need to do? Fantastic. We need to check that the inner 2 dimensions match. If you think back to my context example on Friday, this was corresponding to the number of sandwiches. We need to make sure we have the same number of sandwiches. Okay? So dimensions, and we want, say for example, dimension, so number of rows by number of columns. So these are my 2 matrices. I'm just putting dots there to represent there could be numbers. in order to make sure that we can multiply these two matrices together, we need to make sure those inner those dimensions are the same. Okay, those inner two dimensions are the same. Then we can multiply them. Okay. Then we find the resulting matrix. Okay, so the resulting size, resulting dimensions. Okay, the resulting dimensions come from, well, where do they come from? Where do the resulting dimensions come from? The outer two, right? Okay, so for example, up here, we looked at the outer two dimensions. So we got 3 here and a 3 here, which means that the resulting matrix was going to be a 3 by 3, 3 rows, 3 columns. Yeah? Okay, fine. And then we go through and we find the corresponding elements. So we look at the elements. And we look at the position in which each element is found. So for example, this element here, well, let's go with this element here, right slap bang in the middle, okay, would be second row and second column, which means that we use the second row and second column from each of the corresponding matrices. We multiply the corresponding elements together, then we add them, and that will be the number which goes there, okay? That'll be the number which goes there. So this is really a recipe for working out matrix multiplication. First things first, you check the dimensions, then you go through, check the element position, and that will tell you which numbers you have to multiply. Okay? And remember, it's always rows multiplied by columns. Is that okay? Yeah? Any questions about that? No? Good, fantastic.